All right, so in geez, we're already on week 11. Week 11, we're going to talk about transactions. So we're kind of getting to um, down to the end here. So we don't have too many weeks left. So I guess first off, if you're working on your final project, just know like at this point you should be starting to kind of be to those last few steps, or know that you have a lot of grinding to do there at the end. But either way, we're getting close to the end, so something to be aware of. Um, but anyways, week 11, we're going to focus on transactions, and transactions are basically a way that we can kind of control safely what we're doing. In fact, they're really handy. You'll use them all the time. If you ever go into working on like production databases, there's something that you're going to want to do all the time. And I'll show you why in a little bit. In fact, I use them even kind of in a development sense. Sometimes I'm very habitual in my use of transactions, because it can save you a lot of work. Let's just kind of jump into what save points are, or what transactions are. So transactions are basically ways, they're like save points. I like to compare them to save games, like in video games. So transaction control language, TCL. So I like to compare them to save games. So like for example, if you've ever played Skyrim or any of those games, like right before you go into like the big boss fight or the dungeon, you always want to save the game so that way if something goes wrong, you have you don't have to redo a bunch of stuff, right? And that's kind of the whole point of transaction control language, is kind of that same concept. But in a way, it also helps us from having to do a lot of cleanup, because we can actually kind of create a mess without using transaction control language. So to kind of walk through scenario, I put a scenario in the announcements that had to do with money, because people usually care if like, oh, my bank account got debited $20 for pizza, but I didn't actually get the pizza. That's always a problem. So I like to use that analogy, but I thought we would do something. I thought we would do something kind of fun, that would be, I guess you could say, a little bit more practical, especially as a lot of us are building final projects. So a lot of the times, like when we're doing, when we're building systems, is we have various different like tables that might hold different account information. So for example, let's say that we are building a database that keeps track of like not only a user, but like an account. So let's say like Netflix, for example. Let's pretend like we're dealing with something like Netflix, where let's say, I need to spell Netflix right. Let's say like as part of Netflix, we can share our not only our login, but we can build like almost like a family account. So like let's not say Netflix, so let's use Spotify, because I know Spotify works a little bit better this way. So for Spotify, we can have one account but multiple users. So like let's say it's a family account, we can have up to 5 users. Right? And let's say that at any point, we can kind of create this all at one time. And our 5 users are like, that includes the account holder. So when we like, let's say that I am buying a family account of Spotify for me and my household. So let's create a table account, and I'm going to have it have account ID. It's a primary key and auto increment. Let's have it have a number. We'll call it account number. It's an int, not null. And I'm just going to kind of keep this simple. So we have our account, and then I'm going to have a primary user. And I'm going to leave that null for right now because we don't have a user to connect to it. Let's say created at, we're going to say timestamp default current timestamp nominal. All right, so let's just let's just keep it simple. Let's see if we can create this table. There we go. So we have our account table, and now I'm going to create a user table. And since user is like a reserved keyword, I like to just say let's just say like that. Let's do system user. So I don't have to type that out 100 times. We're going to have a email. Let's do a first name. You know, we don't care about last name, first name stuff. So we're just going to say name. We'll just put it all together because, like, I think Spotify, you can have like other names, like it doesn't have to be like first name, last name. So we're just going to do that. Make that one 100. Okay, so user ID, email, name, and we need a password. All right, let's take a look at this. So we have a user. A user doesn't necessarily have to be tied to an account. Let's also use our created at timestamp current timestamp not null. All right. So there's our system user table, which I'm just going to call user because it's easier. So now one thing we need to do, and this is all just setting up the scenario, so I apologize, but we're going to alter the table account, and we are going to add constraint, and we're going to call it account f foreign key 1. It's a foreign key. That foreign key is on primary user. And it references system user, user ID. There we go. So now we have a constraint on there. And then I'm also going to alter table. You know, technically, I think we can just do this without it since there's not an account there. It's not a circular. So let's just put this here and we'll just recreate it for simplicity. There we go. We're going to make this not null. There. Drop table. And then we'll just recreate it. There we go. All right, so these are kind of our two tables. So when someone registers or someone buys an account, this is kind of the two tables that are going to be created because they'll probably create a user and then an account at the same time. So what we're going to do is we are going to kind of simulate that. So we're going to say insert into, and let's say system user. We're going to insert our email, name, password. We're going to say our email is bilbo@baggins.com. It's actually a number. The password is, normally we would hide that, but we're not going to worry about it. Okay. So when we build a system, most time like you're on like a website and it'll kind of build the thing. Now, depending on how you do this, it may, you could probably mitigate this issue entirely by having someone create a user and then having them register an account separately. But sometimes that's not always possible. Maybe it doesn't flow well with our business logic. Um, you know, Often it happens. There's just sometimes that you have to insert two records at the same time, especially like in accounting, you might debit an account and credit another one all at the same time. And so we're going to kind of simulate this. So we're going to pretend like when you create your user, you pay your money and you create your system user and your account all at the same time. I don't know exactly how Spotify does it, but I know Netflix does it that way, where you kind of like do it all in one kind of shot. So we're going to kind of simulate that. So we have our test case for our system user insert. Now we're going to insert into our account. And our account number, primary user, and created at. Actually, we don't need created at because that's the benefit. I know it's a side case, but having your default there for like your created at, you can just skip it because otherwise it will just put it as the current time. All right, so our account number is, oh, that's a name, not an account number. I was looking at the wrong table. Account number is 0001. And our primary user is going to be, we don't know. So let's just write a little select statement here. We're going to say select user ID from system user where email is equal to bilbo@baggins.com. There we go. So now I'm just going to hurry and test this by running this one and then running this one. And let's see. It looks like we got this wrong. System user Bilbo at, oh, I did a typo. Let's try that again. Need to fix this anyways. There we go.
Can you tell me what you're doing with the truncate and on the cascade? I've not seen that before.
Yes, I will explain that because it's really handy. So basically what that's going to do is, so you'll notice that when I tried to truncate that table, essentially delete the data from the table. And just so you know, the difference between delete and truncate is when we delete something, we can undo it, which we'll talk about in a minute. When we truncate something, it's gone forever. It's kind of like a mass wipe, like clear out the table, which is actually really nice because it's much quicker because we're not trying to log any changes on the database. We're just deleting everything. So especially when you're in kind of development mode, truncate's really handy, just for those kind of reasons right there. So our system user table is kind of the parent, and account, if you were to look at an ERD, is like the child of a system user. So a system user technically kind of owns an account because of this primary user field and account. And because we have this constraint, if I try to delete an account that has a parent supposedly tied to it, it will fail because it says, hey, you can't orphan this record. Or like if I try to delete a system user record that has an account record, we don't want to delete Bilbo Baggins system user, because then we have this account that's kind of lost in the abyss that doesn't have a primary user that actually equals anything. So the database actually, that's part of like what helps it keep its integrity. That's why you actually want to define these constraints, because like, let's say I accidentally try to delete someone's account. Let's say that, I think, oh, this person wants their account deleted, so I'm going to delete their user and their account. If I try to delete their account, but or if I try to delete their user, but their account still exists, it's going to throw an error, which is handy because maybe I, am deleting the wrong persons. And we also don't want to forever lose those records, because then we wouldn't have a good way of finding them, because we wouldn't be able to look up the system user ID to be able to find what account we need to delete, if that makes sense. So what this on delete cascade does is it will, if I delete the system user, it will cascade and automatically delete their account, which you may want, you may not want. Basically, sometimes I purposely leave this off because it does do that check. Because now if I go to delete a system user, it will just delete their account, which in this case, I'm going to kind of want to do that just because that way, like if someone says, hey, just delete my account. Okay, yeah, we'll delete your account, but it's your user. Like you won't be able to log in. We're going to remove your email and everything from our records, but it's also going to delete your account. Now, most of the time, this probably isn't feasible because a lot of times we would probably have transactions like, okay, let's say they paid for Spotify 4 months. We need to keep those transaction records, but that'll all be tied to their account and all that kind of stuff. So maybe we want it, maybe we don't. Anyways, lots of fun things there. But so that's what that does, is it kind of just lets you, in fact, we'll try it right here. So we have our 2 records. If I now delete, or if I truncate system user, up, and I think we need to tell it to cascade. Maybe, I can't remember the MySQL syntax. There's a way we can kind of tell it to force, and then it would kind of trigger this. In fact, let me just look it up real quick. MySQL cascade delete. And it's, anyways, I don't want to get stuck too much on it because I can't find it immediately, but that's kind of the premise for it. So we have our 2 records, and everything went in fine. Everything went in great that time, because we kind of just went it. But the problem is often we need to kind of handle errors when they occur. So let's say that for whatever reason, there's a problem with this account number. So for example, let's say that a programmer messes up or something, and the account number ends up being A0001. Right, so let's delete this. We're going to truncate account and then truncate system user. Oh, and we need to delete from system user. Maybe that's my problem, is we are using truncate, not, there we go. All right, so we deleted everything. We should be back to a clean slate. So now what we're going to do is, let's say that you are on the website and you put in your name, your email, your credit card information, and you go to hit like subscribe, and it runs the first one where it creates your user. Hey, there it is, blah, blah, blah. But then like there was an issue and something went wrong. So then the end user sees the error on the web page and says, well, that's weird. I had to hire a higher bar set for Spotify, but whatever. So you hit refresh and it takes you back to where you put all this information again. And I forgot one step. We need a unique constraint on our table here. Constraint system user UK1 unique. Now we want to have unique email addresses, right? We don't want anyone sharing an email address. It's going to be important to this. There we go. Okay, so now we have our table built the way it should be, meaning that we don't want two people with the same email to be able to register, because then people could do the email password reset and steal other people's passwords. We don't want that. So something breaks, right? We get that error like this. The web page says, oh, error 500, can't do something, blah, blah, blah. So they hit refresh and they go to do it again because they really want to listen to music. Well, if I go to put in my email again, it now throws another error and it says, hey, this record already exists. And we kind of built our system to where you can only log in if you have an account. So now we're stuck in this boat where I can't register, I can't log in, I can't do anything because we have this rogue system user record out there in the middle of nowhere that's not really tied to, it's not finished setting up. Something went wrong. And that something could be that, we had someone typed in a record, some data that didn't work. Or, maybe we pushed an update to the web application that, caused an error where people couldn't register, blah, blah, blah. So one of the ways that we as database developers can handle these kind of situations is with transactions. So let's clean up our database again. I'm going to delete from system user. So let's build this the way that it should. So the first thing that we need to know is that usually when we're in an IDE, it has transaction functions kind of built in. So like for dbeaver, MySQL Workbench, you'll notice like for me, there's these things called auto commit. That means whatever I do, it's going to auto commit anyways. So what I'm going to do is I'm actually going to open a terminal just because sometimes I don't trust our IDEs, even though I think I can set this to manual commit. Let's try it. Let's try it here before I go to the terminal. So what we're going to do is we are going to switch our IDE to manual commit, meaning it's not going to do it for us. You'll notice that there's some buttons here, commit and rollback. We're going to handle that all ourselves in code, but it should recognize it and take care of it. Because normally, like if I were to run a command, it's permanent, just like you guys all probably have been doing when we run a command. It just kind of happens and we go along our merry little lives and we don't have to worry about committing or rolling anything back because we haven't learned it yet. But now we're going to know. So I'm going to change so just know if you want to practice this in MySQL Workbench for the exercises or similar, you need to switch your commit mode to be manual instead of auto commit, because by default, most of them are auto commit. Then what I'm going to do is I'm going to say start transaction. And you'll notice now that in my IDE, this thing turned to a little green 1. That means that like, okay, I have so many statements. I have one statement that's kind of in this transaction, and a transaction is kind of like a little isolated set of changes. So like I said, whenever I about go into a dungeon or fight a boss in a video game, I like to create a save point in case I need to come back to it. And that's kind of what we're going to be doing here. So let's simulate this again. So we started our transaction. We insert our system user. And again, you'll notice that incremented to 2. And now if I run this, oh no, we had an error. And then we would detect that error in our programming, our kind of the program layer, not the database layer. We would say, oh, if there's an error, then execute this command. And the command we would execute is rollback. And now, since we rolled back, if I select everything from system user, you'll notice it's empty. So we did insert Bilbo Baggins. So let's just run through that again. So we start our transaction. We insert into system user. If we select from system user at this point, there's Bilbo Baggins. If I try to do this, it fails. Uh-oh, so we want to then roll back. So if I roll back, now if I check if there's Bilbo Baggins, he's gone. And at this point, we would want to commit. Commit. So anyways, so that's kind of that portion. So basically, let's put a little clause here.
When you actually commit it, does that end your transaction then? That's it for that group?
It will roll it back to wherever we started our transaction from. So yes. So like at this point, when I say roll back, we are now back to here. Wherever we were when we started this transaction, that's where we're back to. And keep in mind, this is only for individual sessions. So like if we're on Facebook or Spotify, like if we're in our current example of Spotify, if 2 people are simultaneously creating accounts and one happens to fail, it's not like everybody has to redo their stuff. You can imagine that would be problematic if, you know, all the millions of people trying to create like Facebook posts or whatever are constantly having their stuff rolled back. So this is only for individual sessions, meaning, okay, I log in, the web server creates a session just for my kind of login. And so if I roll it back, it only rolls back the changes that happened right here in that process thread, if so to speak. So it's not like it rolls back everything in the whole database that's happening. It only rolls back a given transaction for that session, which is really handy. So let's actually make this work the way it's supposed to. So let's say that we fix the error and the person goes to register again. Let's start our transaction. They create their user. They create their account. The system functioned as normal. So I'm kind of just simulating like some Python code or something here. If there's errors, then roll back. If no errors, and we commit. Now, as soon as I run commit, there is no going back. So like I can select everything from system user. I can select everything from account. And it's all there. Now, if I say roll back, and this is where I don't know how the IDE works necessarily. If I say roll back, okay, so it is working properly. You'll notice that it's still there. So at this point, I can no longer roll back, but that's kind of the way that's supposed to work. So basically the flow is let's multi statement process. So I say multi-statement process because really we want both of these to work or none of them to work. Often called an all or none. Because we either want all of them to go through or we want none of them to go through, which is kind of why we do that. And I actually have a good example, a real life example here. Of one. So in ETLs, often we want to, so this is some SQL code that will process data. So every half hour, this process runs and it gets all this data and it puts it into these import tables. And I want to process that data to put it into our production. And so what I want is I want to say, hey, if I've updated everything, then I want you to, you know, then do it. But if something goes wrong, I want to keep it when everything is all in the same playing field, because like on a analytical dashboard, I have, okay, when was this data updated? And when was our most recent data from? And I want that to be true. I don't want like, oh, our orders are up to date, but our order details are not, and no one knows, because it's not very clear. So I want it to all be on the same page. So if something goes wrong, don't do anything. And so that's a good example of a transaction, and you can see that happening here. So you can see, okay, I declare exit for handler SQL exception. So if any SQL exception or error, this is another word for error, happens, it's going to print the errors. So it'll tell me what happens and it will roll back. So if at any time something goes wrong, it's going to roll back the transaction and tell me what happened. So, and that's kind of like up here at the top, which is kind of foreign to some people, but basically it's kind of like a little individual process. So this only happens if something goes wrong. But the real stuff happens here. And so I start my transaction, just like we talked about. And basically what I do is I delete data from the production tables and I insert the new updated information. So you can see like, oh, I don't want to delete this data and have something go wrong and then not have the data, right? I at least want the data there. So that's why I start the transaction. And if something goes wrong, it rolls back. If it makes it all the way to the end without an error, it commits it. So that's another good use case. There's lots of good use cases. So here we are, we're back to our example. We start our transaction, we do our process, like the thing that we want all the things to go through or none of them to go through. And then if there's errors, we roll back. If there's no errors, then we commit. Now, one more scenario. So that's kind of like the more programmatic use case, which is really what they were built for. But I use them very frequently for utility, meaning just like when I'm performing maintenance on a system, they're really, really handy. So what I'm going to do is I'm going to, I think we're already using Sequila. Just make sure we're in Sequila database. Yeah, we're in Sequila. Okay, so let's take a look here. Let's select everything from customer. Okay, so here's all of our customers, right? And let's say we get an email from one of our customers and it says, hey, I want to update my email address. And you say, well, why don't you just use the online email change like your stuff form? And they say, I don't know how to do that, blah, blah. And you say, okay, I'll do it for you. Right? It happens all the time. So we go in here to manually update their information or perform maintenance. Like let's say all of our Sequila customer.org, like let's say we change our domain. That's a good use case. But we only want to change our domain for we changed our domain. So let's say we want to update our domain. So we're going to update customer. We are going to set email equal to, and this is going to be, let's say that we kind of fat finger this, right? Let's say we set our email and we say, oh, I want to set it to sequilamovies.org. Right, like that's our new thing. And we want to do it for all the emails. So we say where email like sent at Sequila customer.org. Now you can probably already see that there's something wrong with this, right? Because I have like their email in front of this. So what I'm going to do, just to kind of simulate why we would want to always do this. So I'm going to say start transaction. And, it's early in the morning. A little tired. So I run this. I'm like, okay, let's check to make sure I got the results I wanted. And I'm like, oh, shoot, we're in trouble. I just broke like all of our data. I'm in the production database. My boss is going to kill me. Well, no, he's not, because guess what? He never has to know what happened, because we can just roll back.
Brother Crook,
Yes.
is this kind of like the setting a save point and being able to go back to that reverted save point when you're putting something through, or is that not live like this is?
Yeah, so that is the same. So what the save points, kind of the difference, they're the same kind of thing. Like you can use a save point in like place of start transaction. But a lot of times what people do is they'll actually put the save points within a specific statement. So like if there's certain points you want to get to and retry, you can do that. So like, let's say at this point, I could say, we could say start, or we could say save point. Let's call it user created.
Now this kind of looks like that cascade that you were talking about, where it would save as long as it's correct up into a certain point, or you could roll it back to a certain point in the transaction.
Correct, because this kind of gives you like more fine-grained control. So let me actually hurry and commit this just to make sure we're good. I didn't break any emails. Okay. So like back to this example, I'm going to start a transaction. Let's insert our user. Oh, and let's first delete our stuff here and commit that. All right, so let's start our transaction. We're going to insert our test user. We're going to create the save point. Now at this point, like I could go create this user account, and then I could say roll back to user created. And now if I select everything from user, I thought I had that somewhere, but maybe I don't. You'll notice that we still have Bilbo Baggins, but if I select everything from account, you'll notice that we don't have an account. So if you want multiple save points within a transaction, you can have more fine-grained control. Now, if I want to just roll back the whole transaction and then select everything from system user, the whole transaction is undone. So like maybe like you're doing like a big long process, like a big maintenance process. This is a use case that I actually found save points to be really handy. Is like there was a time where I had to like go through this whole process where I would have to manually create like a user. Then I have to manually create like another subset of records. So this is when I was dealing with school data. So what I was building like a bunch of pre-built assessment data. And I was kind of fabricating it as I went. So I was saving myself a lot of time, but obviously not all the time are you like writing the whole script and just hitting run and letting it all go. A lot of times like you're, building one thing, just changing a value and running it again, kind of a thing. So what I would do is I would create the user, and then I would create like some basic like assessment info, like the parent record, and then I would create like essentially all the questions on the test. But I would do that, and I had a kind of like a really efficient way to build that across multiple grade levels that all had different tests from this import data I was creating. Anyways, long story short, because we are human and we make mistakes, what I would do is I kind of built it out just like this, where I would only have to change a couple of values and then I would run manually each step. But that way, if like, oh, I accidentally typoed this, it's not like I had to redo a bunch of stuff. I could always just go back to the last thing that worked, fix my mistake, and rerun it, and it was like it never happened. So, like in this case, if I was going through a pretty complex process, which this one's not, I could say, okay, let's insert into system user. Like let's say I just got the wrong account number, right? So I'm going to create my save point user created. I'm going to create my account. I'm going to do my save point account created. And let's say I go to select my info to make sure that it's all good. And I realize, oh, shoot, I have account ID 3 instead of 2 or 1 or whatever. Like, let's say it's supposed to be 1. I can roll back to user created, fix my mistake, rerun this, create my new save point, check it. And now my account number's 1 like it should be. And then I can commit. So we still use the transaction, our start transaction, but the save points kind of give you a reference. So you can kind of split your transaction into multiple places to go back to. So it's kind of like a save within a save. Does that make sense?
Yes.
Perfect. Great question. And like I said, a lot of times these are used like programmatically. So as you can imagine, like banking transactions, like in my example I gave, like where in places where you need to be so precise, like stock market, banking, scientific data, even like, really basic feedback, like controls and that kind of stuff. We need to be very precise. And in those cases, it's built into the way that it's programmed. So like, like when someone hits the save button in Python, what do we do? Do we run it and that kind of stuff? But you can utilize these transactions within your Python. So I actually do a lot of API work, and those APIs will actually run start transaction. Like I'll actually execute that command against the database, do my work, and then commit it or roll it back, depending on different logic. It can also use the save points, which is also handy for various things. So they're obviously very handy. Sometimes they're programmatic handy, but the nice thing is like even for day-to-day use, like while you guys are building your final projects or just playing around. So like let's say we wanted to just have some fun with our Sequila database, we can always start a transaction and we can delete from customer, which obviously is going to be a problem. Let's like we did, let's update email. We can update our customer. Now all their emails, Billy, we can just play around. So like maybe we're just trying something out. Like, oh, like I just want to see what this would look like. Or I want to see if I can set the email equal to like a new domain, like our previous example. So let me roll that back. Let's make sure we're back to normal, which we are. Let's just do this. I want to try and make sure I understand this. So I'm going to replace at sequilacustomer.org. And I'm going to replace it with at sequilamovies.org. Don't forget to start your transaction. That's the biggest thing you can do. It looks like I have an issue somewhere. Maybe that's not how the replace function works. Let's see. MySQL replace. Oh, I probably need to give it a, there, let's try that. There we go. So now let's look. And there we go. So that time it worked. So now that I have successfully done what I wanted to, I could then commit. But in this case, I don't want to because I was just trying it out. So I'm going to roll back and we're back to normal. So they're very utility in the sense that, you know, you can try a bunch of stuff out. I guess just as another save point changed. Let's start a transaction. We're going to change their emails, create our save point. I'm going to take our same thing, but I'm going to fix it back the way it should be. So we're going to take sequilamovies.org and basically put it back to how it should be. So now we should be able to select everything from customer, and it's sequilamovies.org. Let's create another save point. Now if I do this, select everything from customer, we're back to normal. But then I can roll back to changed. Select everything from customer. Or I can roll all the way back. So they're really nice for utility stuff. If you're just kind of like wanting to play around, do some incremental stuff. So like in this case, I can make sure like, okay, I'm going to do the fix and make sure that I can undo whatever I did in case I did something wrong, and then verify the changes. So I use a lot for that. Like if I'm performing a maintenance task, like a lot of times I'll just do a test run where I say, okay, start a transaction. Let's see what happens. Once I kind of do everything, a lot of times it's like, okay, I'm doing stuff on the back end, but I want to check the actual website where that's driving this. So I'll say, okay, start transaction, make the changes, go open up the website, see how it looks. If it looks good, then I'll commit it. If something broke, I'll say roll back. So lots of handy little things. All right. Does anyone have any additional questions about transactions?
I'm sure I will after the quiz, but I'm not there yet.
Okay. Yeah, the nice thing is they're not too transaction control isn't too complicated. There's really only like a few commands involved. So if you understand the concepts, they're not too bad. There's a couple little things that they might try to trick you with. Like, let's just try this because I don't know how MySQL behaves, to be honest.
Well, and I noticed that you could set auto commit to be 0 or 1 to turn it on or off in your session.
Yes.
Rather than clicking a button and hoping it saved it in case you close something.
Yep. Okay, so one thing to remember, I don't know if they'll try to trick you with this, but one thing to remember, so like in our little process here, you'll notice that I did start transaction, we updated the email, and we did a save point changed, and then we fixed it, reverted it back to normal, we created a save point called fixed. If I roll back to changed first, and then try to roll back to fixed, which is after changed, you'll get the save point fixed doesn't exist. So remember, if you roll back to this save point, this stuff never happened. So I can't remember if this is on the quiz or not. I'm just kind of theorizing if I had to build it, what I would put on there. Like if they said, oh, what would be the result of running rollback to fixed given this these commands were run. Roll back to fix with throw an error, because once we roll back to changed, this stuff is never happened. So save point doesn't exist. That makes sense. All right. Well, I don't want to keep you any longer. Does anyone have any final project questions? All right. Well, I won't keep you any longer. Thank you guys for coming. If you have any questions, let me know. Otherwise, have a great week.